So far, you've looked at some videos related to ionic compounds that have just one charge for the metal. If you look them up on the periodic table, you're going to see it's groups 1 and group 2 that only have one possible charge that are listed. But groups 3 through 12 have several possibilities for a large number of these elements. We can't just take the top number. That would be awfully easy and convenient, but not always true. So in order to accurately show which of these ions we're referring to, like for chromium, there's 3 possible charges. Some compounds will have chromium with the first charge, some with the second, and some with the third. And there's a way that we can show in writing, inside the names, which particular ion for chromium we had used. The first step is just like before. We're going to be showing our cation, which is our metal, followed by the anion, which is our nonmetal. The sum of all of the ions is going to have to add up to 0, and we saw this when we wrote our ionic Lewis dot diagrams several units ago. When we go to crisscross these, just like we're going to do from the unit topic before, we want to make sure not to adjust the charges. The charge will either be given to you in the problem or it's what we're solving for. The only thing that we have the ability to change is the subscript. That's the little number at the bottom after each of the elements. When it comes time to name the compounds, we will actually be using Roman numerals to do that. And the Roman numeral will tell us exactly what charge we used on each of the metals. In order to do this, you need to know your Roman numerals. So let's recap them quickly. The Roman numeral 1 looks like a capital I. So here's a 1. Sometimes it's drawn without the top the top and bottom line. Roman numeral 2 is the 2 lines. 3 is 3 lines. 4 is IV. V is 5. 6 is VI. 7 is VII. We don't generally go above this, but just so you know it, 8 is VII, so it's 3 I's. 9 is IX, and 10 is X. Okay. When we go and we try to come up with the name of our compounds, notice how these have inside of them Roman numerals. The Roman numeral 3 is telling us for every iron inside the compound, the iron will have a +3 charge. Oxygen, just like in the last segment, is called oxide, and we will be crisscrossing the iron with the +3 and the oxygen. So our +3 is in green to illustrate where it came from, and the oxygen, we're taking our top oxidation state, it's a -2. When we crisscross, this 2 will come down over to the bottom right of the iron, and the 3 will come down to the bottom right of the oxygen. And you will have Fe2O3. This cannot be simplified, so this is the final formula. This is also called rust. So if you have a car and it has a rust spot, this is the compound. The next example is copper, Roman numeral 2, chloride. The Roman numeral 2 tells us we have copper with a +2 charge. Chloride, we'll look up on the reference table, the top charge there is a -1. When we crisscross them, we will get Cu1Cl2, but out of habit we don't write 1s on the bottom, so it shows up as CuCl2. Even though chlorine on the reference table has several choices for the oxidation state, we will never be using Roman numerals for nonmetals. For our nonmetals, we will be taking the top oxidation number, the one at the very top of the box, and using that value. For the metals, anytime there is more than one listed oxidation state, we must show which one we're using with a Roman numeral. Please note that the reference table also includes only selected oxidation states. In reality, there are a few that are not listed, although they're fairly rare. So if you have a problem that requires you to use an oxidation number that is not listed on your reference table, that's okay. It's just one of those rare instances that the reference table doesn't have it covered. To go backwards from a formula to a name, it's almost like doing detective work or a puzzle to figure out what oxidation state your metal needed in order to make a neutral compound. So our first example will be Au and Br. Au is gold and Br is bromine. When we look bromine up on the reference table, we see each of the bromines will have a -1 oxidation state. That adds up to a total of -3. The charge that we will need for the gold will have to be something that will make this whole compound neutral. And in order to do that, the gold needed to be a +3. When we go to name this, arrow, gold, Roman numeral 3, bromide is the proper name. And that's because your gold had a +3 charge. Over on the second example, we have Pb, which is lead, and oxygen, which is called oxide. Pb and 2 O-. In order for this whole compound to have a total charge of 0, our lead needed to have a charge of +4, making the name for this lead, Roman numeral 4, oxide. Notice how if you were just going to be crisscrossing this 4 with this 2, you'd have Pb2O4. That will simplify to PbO2. We always want to show our formulas in the simplest ratio between the atoms involved.